Hey everyone, my name is Kevin Jones, Senior Product Manager at NGINX. And today I want to talk to you about the powerful and efficient architecture of NGINX. So if you're not familiar with NGINX, NGINX got started as a reverse proxy and as a web server, and it was originally created to actually sit in front of application and web servers at the time that couldn't handle more than 10,000 concurrent connections. Designed by Igor Sisuev, he created NGINX with an event-driven, asynchronous, and non-blocking architecture. What's unique about NGINX is it does have a master worker process that's in charge of doing all of the high-level disk operations. Things like opening up log files, reading and writing to that log file, maybe opening the config file and reading that in, managing the process ID. Really anything that needs to happen at that operating system level is handled by the master worker process. It also can spin up additional worker processes that can essentially sit underneath it. And these worker processes are awesome because they can do all of the connection handling. They can do all of the reverse proxy functionality, being able to read in things like the request URI and the headers and different HTTP level information that might be coming through that needs to be handled by these. And it's doing the request processing and passing that on. And we'll get into that in just a little bit. And additionally, these workers can also, and actually by default, are set up to use what's called CPU affinity. So if you have a specific number of CPUs in your system, you can create an identical amount of workers and have these workers actually bound to those specific CPUs. So this lets you really optimize the amount of CPUs that are in your system, and each worker can have a dedicated CPU at doing all of these complex, intense CPU-intense operations. NGINX also can act as a content cache, and it can serve static files. So static files, content cache, you can also write to temp files if need be. And so it can do disk operations as need, right? And pull stuff or write to as needed as well. So it has a robust way to do that stuff. And then if there's anything that I mentioned before, it is event-driven, asynchronous, and non-blocking. So if there is something that's going to be potentially a blocking operation, it also supports threading. So it can also spin up additional threads to handle that long operation so that the worker can continue doing what it needs to do. So this really makes the architecture stand out. Now, you would say, well, how do these workers really keep track of the information that's going on throughout the proxy? Well, NGINX also has what's called shared memory zones. And these are zones that can be configured and managed so that they can share the state of what's going in the background in these workers. So things like health checks, or if there's some kind of information about a server being down and it needs to let the other workers know, it can do so. If it needs to keep track of DDoS protection, you might limit the amount of connections. So you would create a shared memory zone that keeps track of that, and that could be shared. There's lots of use cases for shared memory zones. And anytime you enable a feature in NGINX, usually if it is something like that, it has a shared memory zone. And this makes it highly effective and highly efficient, not only from a CPU standpoint, as we mentioned, but also as a memory. And so that's why you'll commonly see that NGINX does not have a very large memory footprint. And so this is really, really great, and it does make sense of why NGINX is so greatly adopted. But how does it work when it comes to connections and actual connection handling? So you might have clients that are over here, and these clients usually want to talk over a certain protocol. So they might want to talk like HTTP or HTTPS. They might also want to talk like TCP or UDP, or some other complex. They might want to talk HTTP2, right? And so it's important that these clients need to be able to come in, and these workers need to handle that. And so by default, the workers actually will take turns accepting these connections as they come through, okay? You can change that behavior. So if you want a particular worker just to accept as many connections as possible, you can change that behavior as well. But it's important to understand that the workers are going to be optimized out of the box when you set up NGINX to handle the connections in a robust way. But if you do need to tweak it, there's a lot of functionality you get that allows you to do that. So then on your upstream, well, you might have like a set of web servers that are talking HTTP, right? You might have or maybe they're talking HTTPS, right? You might have a set of database servers that are sitting back here that are TCP. You might be running some kind of like DNS service as well, right? That's using UDP here. And you might have something that actually is using like WebSockets as well. And the important thing to know is that NGINX can reverse proxy to all of these different protocols, and it can be configured to handle these type of reverse proxy connections. And so this all together working makes NGINX highly effective when it comes to handling connections, processing those requests, reading in the headers, making decisions on where that traffic needs to be routed, and really makes it a well-oiled machine. And it's commonly why NGINX is used as a Swiss Army knife of the web, as you would say. So I hope you found this interesting, and I hope you learned a little bit about NGINX today. We would love for you guys to follow along on future content, so please subscribe to our channels, follow us, and let us know if you guys want to see anything more about NGINX. We would love to have you guys in the future. Till then, I'll catch you guys next time.